This video is going to review some of our solving equations steps as well as go one step further with one new thing in this video from the previous ones. Solving equations, two-step problems. Solving equations is finding values that make an equation true. When we are solving equations, we are solving for the unknown number, represented by a variable that makes the left side of the equation equal to the right side. So when it says in example 1 solve, we're looking for what value of x makes the left side equal to the right side, which happens to be 5. So what value of x makes both sides equal to each other? That's what solving means. So as you recall, we usually want our variable on one side. We basically want to say x equals this, and we want our numbers on the other side. So this 20 that's beside the negative 5x, I want that gone. So in order to do that, I can do the opposite of positive 20 and do minus 20. If I subtract 20 on that side, I have to subtract 20 on this side. That keeps that balanced. Okay, so I have to do the exact same operation. So 20 minus 20, that just disappears. All I'm left with is negative 5x here. And then 5 minus 20 is negative 15. Okay. Now, the opposite of multiplication is division. This negative 5x is multiplication. So I need to get x by itself. I just want to know what x is, not what 5x's are. I want to know what x is. So I'm going to divide both sides by negative 5 to keep things balanced. The opposite of multiplication is division. Negative 5 divided by negative 5 is just x, just 1. Anything divided by itself is 1. And the other side, negative 15 divided by 5 is 3. So here's something we haven't seen in B. Okay. So first I have to do what I previously learned, and that's my distributive property. Okay. So that becomes 3 times x is 3x, and 3 times negative 1 is negative 3. That equals to 12. Now that looks similar to A, so now I'm going to do the exact same thing. I want the x on one side and the numbers. So opposite of negative 3 is positive 3. So if I add positive 3 there and I add positive 3 here, I'm keeping it balanced. So then what I do, this becomes 3x. And that's just because that's 0. I don't need to write 0. And then that's 15. So now I'm back to 3 times x. So I divide that by 3. We get it by itself, because 3 divided by 3 will give me 1. And I have to divide the other side by 3 as well, because I'm keeping things balanced. So that becomes x equals to 15 divided by 3 is 5. Some more examples. So again, I want my x's on one side, numbers on another. So this number here, I want to get rid of it there. So I'm going to subtract 6 from this side because that's the opposite of positive 6. Then I have to subtract 6 from here as well. And then I can simplify my like terms. So let me just leave this as 5x minus 2 for now. That's 0. And negative 12 minus 6 is negative 18. Then I do 5x minus 2x. Collect my like terms. That's 3x and negative 18. Okay, and my last step is to divide both sides by this number, 3. Okay. So x is equal to negative 6. So let's look at some more examples. So remember, solving is like almost the opposite of BEDMAS. We're doing multiplication, division, adding and subtracting first, and then multiplying and dividing. Here's some they seem more complex. So again, your idea is you want to pick a side for the variables and pick a side for the numbers. So I like to see let's say I like the variables on the left side, so I don't want this 3 here. So first I'm going to subtract 3 from both sides. That disappears. 3 minus 3 is 0. And then I'm left with 9 minus 3, which is 6. I still have a problem. I don't want this negative 2x on that side. I want on the other side. So I'm going to add 2x. X plus 2x becomes 3x. That is 0. I made it disappear. And it's equal to 6. And I always know my last steps look very familiar. Usually I have a number in front of the x that I have to divide on both sides. So 6 divided by 3 is 2. Okay. Again, so I found that number 2, if I plug it in here, and if I plug it in here, I should get the exact same thing equal on this side as that side. That's what solving means. Let's look at the next one. I don't want this one here. I want to get rid of it. So I'm going to subtract 1 from both sides. Opposite of positive 1 is subtract 1. So that leaves me with 3x here, as that's 0. And then 5x. These are like terms, so I'm going to subtract 5 minus 1 is negative 6. Again, I run the same problem. I have a 5x here. I want that x is all on the left, so I'm going to subtract 5x here, because that's positive, and do the exact same thing on the other side. Okay. 3x minus 5x is negative 2x, and that's 0 equals negative 6. Last, we divide by negative 2. Number divided by number is always itself. So the same number divided by itself is the same. That's just x. And then negative 6 divided by negative 2 is positive 3. Negative divided by negative is a positive. All right, a couple more examples. So remember, we want this variable, 3x, I want it on the left. So I'm going to subtract negative 3x from here, because that's a positive 3x, and I have to do it to the other side. Okay. So that leaves me with 5x minus 3x, which is 2x. That's 0, so I don't need to write it. I'm just left with negative 8. Now divide both sides by 2. And that means x is negative 4. This one requires distributive property. So I'm going to distribute first. 3 times x is 3x. 3 times negative 2 is negative 6. So it's a 9. Then I want this variable by itself. So I'm going to add 6 here and add 6 here. Nine plus 6 is 15. That disappeared because remember, it becomes 0. And then lastly, I'm going to divide both sides by 3. And lastly, negative 2 times 3x is negative 6x. Negative 2 times positive 8. Negative 8 becomes a positive. 8 times 2 is 16. And I just write the other side as is. Now I want to make sure I get my variables on one side, numbers on the other. I want this 16 on this side to disappear, so I'm going to do the opposite of positive 16, which is minus 16. But in order to keep it balanced, I have to do it on both sides. So this becomes negative 6x. That's x. 2 minus 16 is negative 14. Still have this x I don't want here, so I'm going to do subtract x on this side, because that's the opposite of positive x, and subtract x here. That leaves me with negative 7x equals negative 14. And lastly, divide both sides by 7. So then x equals 2. Negative 14 divided negative 7. Negative divided by negative is always a positive.